Mistake. Here we are on the main stage downstairs. They're doing another one. So you have your choices. I understand the live stream downstairs is having a little bit of an issue, but up here we're doing okay, which means we'll start. This is Dan and Joe.
Hello. All right, so we're here today to talk to you about SpiderLightning, a new kind of cloud systems interface. And I feel like right off the bat with this slide, we probably have lots of questions, as in SpiderLightning, cloud systems interface, new, right? So let's start answering one of the easy questions, which is, who are Dan and Joe? Well, I'm Dan. I work with open source software at Days Labs Microsoft as a software engineer. Work with Rust, WebAssembly, and I like that tech so much that on my free time, I also teach people about it. So if you want to check it out, I have a YouTube channel where I teach people Rust, WebAssembly. It's called Danlogs. When I'm not doing Rust and WebAssembly, you can usually find me watching Star Trek or playing Super Smash Bros. Ultimate or going for medium distances like 10K interval runs.
And I work very closely with Dan on various open source projects at Days Labs, including SpiderLightning. Since the pandemic, I started attending a lot of virtual meetups, and I personally hold a virtual meetup called System Gossip Meetup.
All right, so what are we talking to you about today? This is the agenda. We'll start with presenting to you a problem. You can think of it as sort of like the motivation behind SpiderLightning, whatever that is. Then we'll talk about one approach, which, surprise, it's SpiderLightning. But that will be sort of just a high-level overview narrative kind of deal. We'll then move on to a deep dive into SpiderLightning itself and its trusty companion, Slight. And then we'll get more technical. We'll talk about what powers SpiderLightning, move on to a tutorial on how you yourself can get started with SpiderLightning and Slight, and then a little showcase, sort of like how far you can go with this app demo that we've made. Finish off with a little call to action. Okay, let's begin with the problem. The problem is engineering distributed applications is hard. And to illustrate that, I want to introduce you to a friend of ours, Person A. Now, Person A is a developer at the start of their career. So they, sort of out of university, they just started at a consultancy, a tech consultancy firm. And they're ready to go, ready to develop some cool software. And they just got their first client. It's the one and only, the renowned Company A. Now, Company A tells them that they want to build an on-premises service to do this, this, and that. Now, I mean, Person A is really excited because, I mean, this, and that's like really an opportunity to impress. So, Person A gets started. And now we're talking about several months later, they developed this really cool app that does this, this, and that. And we're 1 week away from the deliverable. They have a meeting with Company A, going to show the app. But the unexpected happens. Company A approaches them and they say, actually, scratch that. We want it on the cloud. I mean, they're Company A. We're not surprised. They can do whatever they want. They're so renowned. And Person A doesn't mind. I mean, we have containers, we have Kubernetes, we'll just, move on-premises cloud. Not a big deal, we'll figure it out. Until they hear the rest of the sentence, which is, and on IoT devices, and CDNs, and edge networks. So now we have a problem, because, I mean, it could be that it's too heavyweight, or maybe we'll run into issues with it not being platform agnostic. So Person A panics, and does what I feel like everyone should do in this situation. They decide they want to explore other opportunities. And the other opportunities that they do explore is SpiderLightning. So they leave their first job and go learn about SpiderLightning, a new system interface for the cloud. Spent a couple of months learning about it, learning about WebAssembly, learning about all these cool things, and now they're feeling ready to re-enter the job market, and they do. And they say a lightning never strikes one place twice, but maybe a SpiderLightning does, because believe it or not, when we have person A again, they get, once again, company A at their new job wanting to make an on-premises service that does this, this, and that. So person A, I mean, they're a change person at this point, so they'll develop with SpiderLightning, they'll develop with Light, which we don't know what they are yet, but they'll use it. And so now, several months later, 1 week before the deliverable, when company A approaches them and they say, we want it on the cloud, IoT devices, CDNs, Edge, whatever, person A doesn't panic. They'll use SpiderLightning, they'll use Light, and with only one configuration line change, they're good to go. That is sort of the motivation behind SpiderLightning. With just simple changes, you get to go. No code changes, you just change the configuration, you're good. What you had on the premises, you now have on the cloud. You have IoT, you have CDNs, you have edge networks. So how did SpiderLightning do all that? Let's get a bit more into that deep dive right now. And the answer is it didn't, at least not by itself. SpiderLightning is backed by WebAssembly. And WebAssembly by itself is bringing a bunch of the benefits here. So it's bringing the fact that it's lightweight, the fact that it's portable. And WebAssembly is doing that all by itself. But SpiderLightning, as sort of its name implies, is just this phenomenon that of like lightning on the underside of clouds. It's fast, and fast sort of in every sense of the word. It's well, the tech itself is fast, but it's also fast in terms of developer productivity. So without any code changes, just one configuration line change, you go from premises to cloud A. There you go. Okay, I mean, what is SpiderLightning, right? We're talking about all this, and one way that we like to think about SpiderLightning is this sort of like these collection of Lego pieces. So we have several interfaces, i.e. the Lego pieces, that all come together. So you have a key value store Lego piece, you have a message queue Lego piece, you have a pub sub Lego piece, HTTP, gRPC, distributed locks, runtime configs, and you put that all together to build, of course, a mobile crane MK2, which is analogous to your application or whatever is this, and that person A built. And we do that, so you can imagine right now, SpiderLightning, we sort of set the ground floor. We have these interfaces. They're sort of this blank slate of key value, message queue, pub sub. And at the beginning of the presentation, I mentioned a companion, Slight. And SpiderLightning comes together with Slight, its companion, which is sort of this, well, not sort of, it is the CLI that brings specific implementations onto these interfaces. So make use of these interfaces, a key value store, message queue, pub sub, distributed locks, runtime configs, HTTP, and makes use of it, and then you can use it on the CLI. So say you have your project with that has a key value store, and it's on premises, is using a file system, making use of the key value interface. You can then, if you're person A, just change it from that file system to say Redis or Azure or AWS. Sort of the idea. So that is SpiderLightning, that is Light. Let's now get a bit more technical and talk about the technology that powers it.
First, it tries to achieve near native code performance. And why do I have to put a near word here? It's because WebAssembly is not a physical machine code. It's a virtual code that you compile to the underlying architecture like x86 or ARM, and then run the machines. So the actual compilation time makes it suffer a little bit performance, but it's near native code performance. And it is designed to be in a very compact form because it's a compilation target, so there are a lot of optimizations that come into the compilers when you compile your programs to WebAssembly. And imagine this, the server sends JavaScript code to the client versus the server sends WebAssembly to the client. The latter way is much more, the size is smaller, and so it has low latency. And WebAssembly runs in a virtual machine, and one of the biggest design is its security, and it emphasizes on software sandboxing. And what that means is the runtime actually inserts boundary checks into the WebAssembly modules to make sure that every WebAssembly module cannot escape it from its linear memory. And that means if two WebAssembly programs are running in the same machine, they cannot violate the memory of each other. And that makes it super secure and also makes it portable. So I want to show you a quick example of a WebAssembly program. We want to write a factorial function, and which takes an integer and checks if it's smaller or equal to 1. If it's, then return 1, otherwise recursively call factorial n minus 1 times n. And the code on the right side is a WebAssembly text format, or WAT in short. And it starts with a module, which is the smallest unit of a WebAssembly, runnable WebAssembly. And inside of that module, you define functions. That function has a signature of parameters and return values. And WebAssembly is actually typed. So when you compile WebAssembly, the verifier will do some type checkings to make sure it makes sense. And at the end of the module, it exports this factorial function to a given name. So now you can use the JavaScript API to instantiate and stream this WebAssembly module, get the object, and then get the exports of that instance of the module, and invoke the factorial function. And that's how you run WASM in JavaScript. The latest and proposal to WebAssembly I want to highlight is the component model, which actually is a combination of two early proposals. One is called interface types, and another one is module linking. And the idea behind the component model is that WebAssembly types are great. They have I32, I64, floating 32, floating 64, and they are so general they can represent basically everything because they are apparently pointers to the memory address. So it can just represent any value in the memory. However, if you want to do language interpolations, you still need those higher level types like strings, union types, records. Imagine if you have a string, but without that type, you have to do like a pair of two integers. One represent the start of the string, another one represent the length of the string. Then it's hard to interpret that function, what that function do. So we really want higher level types. And another benefit is to dynamically link the components in the runtime, so we can kind of compose components together to form a bigger component. I like to quote Dan Goleman from Fastly, and he has the most concise one-sentence description of the components. And it says a WASM component is a deployable unit of software. And that deployable word is pretty important. It means that it's usable outside the box. It defines how to execute a component. So you can think of the component as a executable in native code. All right, so I've mentioned several design goals of WebAssembly, and let me just summarize them. And the first is security, and second is portability, and the third one is performance. And those design goals align with the browsers. But we also think those design goals are pretty valuable for WebAssembly to run outside of the browser. And in the clouds, in edge networks, in embedded devices, and other places. But there is one problem. When you bring WebAssembly outside of the browser, how does it talk to the underlying operating systems? Imagine you have a program that prints hello world. That program, when you compile to the machine code, it has to use libc to talk to the operating system to get the file descriptor, to write to that file descriptor, and call proc exit. So WebAssembly is not designed to have those APIs. So that's where the WebAssembly System Interface, or WASI, comes from. It is a standardization effort by WebAssembly community group under W3C to design a system interface API for WebAssembly to run in various operating systems. And one thing I want to point out is it's a virtual system interface, meaning that it doesn't tie into any of the architectures or Linux or Windows. So to use the same analogy, WASM is a virtual architecture, and WASI is virtual operating systems. And so now, if you have a C program that prints hello world, when you compile that program to WASI WASM, you can see that the WebAssembly module actually imports a bunch of WASI APIs, and those are imported WASI snapshot, preview 1, file descriptor close, file descriptor get, seek, write, and pro exit. And the WASI provides those APIs for the WebAssembly module to talk to the operating systems. So now you can run it outside of the browser in the host. We'd like to extend that analogy to above and beyond. WASM is virtual architecture. WASI is virtual operating systems. And we want something that represents a virtual cloud-native APIs or a virtual distributed application capability APIs. And that's where SpiderLightning is. You can think about it as a bunch of profiles that extend the traditional POSIX like WASI to have capabilities for your distributed applications like key value store, HTTP, message queue, distributed logs, etc. And we are working closely with the community to drive the specifications for those capabilities. And if you're not familiar with WASI, they have proposals, and each proposal has like different phases. And SpiderLightning capabilities are WASI phase 1 proposals, and that means the community agrees that it's very valuable to drive further designs and specifications for those capabilities. And here I want to shout out to tomorrow's WASM Day. It's a co-located event at KubeCon where there are a lot of talks about the component model, about WASI, and you should take a look. All right, so to just go into more details, the component model comes with the IDL to define your interfaces. And that IDL is called WebAssembly interface types. So I'm showing one of the capabilities in SpiderLightning, which is key value store. So you can write the key value store interface in this WAIT syntax. It starts with a resource kit called key value, and it has a bunch of operations: get, set, keys, list keys, delete, and watch. And we have other capabilities also written in the WAIT files. And the point is that these are interfaces, and anyone can write an implementation for those interfaces. Slide introduced by Dan is an example of host implementation for those interfaces.
All right. So right now we're getting into tutorial time. So how can you get started with Light and SpiderLightning? Now the venue is cleverly designed so that I don't show up on screen if the demo fails. So I'm just going to walk over here and bring up the terminal. Going to open a new window. And hopefully we can make this big enough. Is that? Yeah? Okay. So, before coming here, what I did is I just installed WebAssembly things and installed Light, which is just one simple command. If you go in our GitHub repo, you can install yourself, and it's very easy setup. But when you have that done, all you have to do to start a new Light project is you can say Light new, pass in a name for a project. We'll call this one Spidey, and a specific version of the key value, or not the key value, the interfaces that you want to use, like the key value one. So we'll say V01. And next up, you say the language of project that you want to set up. Right now, we have it set up so you can have C projects, Rust projects. So for this example, I'll start a new Rust project. Now that will work, all right. Now let's CD into Spidey and quickly ls. So if you're familiar with Rust, you'll see we have a cargo toml file, just a manifest. You have a Slight file, which is the configuration file for Slight, the one that person A just had to change one line for. And source folder just has our main business logic, and a wit folder, which contains the interfaces that we're using. So let's check out that wit folder. We'll go to wit, we'll ls, and you see we're using the key value interface at 001 or 010. And that's just the interface that Joe showed a couple of slides ago. Exactly same thing. Now let's cd back and show, let's show this light file. So in here, you see we're using a spec version of 01, hopefully. And you're using a secret store, so we're loading configurations from environment variables. We're not actually making use of any configurations, but it's there just for display purpose. And you're using one capability which is a KV, so that's the interface, and file system, that's the implementation. So one side you have SpiderLightning, bring in the KV. One side you have Slight, bring in the file system. And so I actually display the business logic that we have. So cding into source, I'll do a cat on our main file. And in here, you can ignore sort of the first lines. That's sort of just generating the code that comes from our interface and generating specific error implementations for our error type. But that aside, the main thing I want us to focus on is that we're opening a key value store, which we called my folder. We're then setting a key on that key value store, which has a key of hello SpiderLightning, and it says the value of hello SpiderLightning. And we're then printing that. So, I mean, you can imagine when we run this, if it works, we'll get a nice hello SpiderLightning. So let's cd back. Now, to build with Rust, you'll say cargo build, and we're going to target wasm32 WASI. And this should take 6 seconds. If anyone knows any 6-second jokes, never mind. It is done in 569. Okay, with that, we now have a WebAssembly module that we can run with Slight. So let's do exactly that. We'll say Slight. We'll pass in our configuration, our Slight file. And then we'll do run. And we'll pass in a WASM module. When you build with cargo build, that should be located instead of target. wasm32, and we build it in debug. So we should have a spidey.wasm. Hello, SpiderLightning. All right. So that is how you yourself can get started with SpiderLightning. And if you want to add new interfaces, we also have, with the CLI, you can do Slight add other interfaces, add runtime configs, whatever you want, and have fun with it. But other than that, we also want to show, because that's not cool enough, we want to show how far you can go with Slight and SpiderLightning. And to show you just that, we've prepared a demo of a chat app, which I will boot up. So we can close this terminal. Now, we developed this using U on the front end. That's a Rust front end framework. So it's all WebAssembly on the front end and on the back end. So let's start that right now. We'll do a make serve. That boots up our front end. Good. We're running. We'll do a make run. This boots up our back end. Good. And this is being backed by Redis. So we'll run Redis server. Cool. So right now, if we go to 127, we get something that looks sort of like a chat app, or will look once I zoom in. All right, so on the bottom, we have what you want to say. That's sort of the input text field that you can say. And on the top, you see that we're logged in as this very user-friendly line of characters. But I mean, a chat app isn't much with only one person. So let's get another user in. And there we go. We have another user. Let's put them side by side. 1 and 2. And now, fingers crossed, when we say hello, we get hello on both sides. And we can say hi. And we get hi. Oh, I should have said that with the other user. Let's say hi with the other user. And there we go. We get it on both sides. And that's entirely powered by Slide. You on the front end, Slide on the back end, which Joe will explain more just about now.
Yeah, we are out of time, but I will quickly mention the architecture that powers the chat app backend. We have two microservices. One is the HTTP server that listens to the request of send request and get message request. And we have a dispatcher service that just dispatch the messages to all the users in that group chat. And those two services are compiled to WebAssembly with SpiderLightning capabilities and run in Slide. The HTTP server is using a message queue capability to send the message to that queue so that dispatcher can get the message from the pop the message from the queue, and it's also logging the users into a key value store for persistent reasons. And that dispatcher will dispatch the message to the user queues. So each user in a group chat will have their own queue to get the messages. So each GET request come to the HTTP server, you will locate that user-specific user queue to get a message outside of the queue to return to the front end. And believe it or not, those two microservices can be uploaded to a Docker container and run in a Kubernetes. And that Docker container for each service is about 600 kilobytes. So that Docker container only have one slide file and one WASI module, no operating system on top of it. And that's it. Thank you, everyone, for listening.
Yeah, thank you so much.
Joe has the mic, so because that little thing is kind of a little flaky. So any questions? Go for it. Screening with questions. I have a question.
Go ahead.
Joe, can you repeat the question for the stream? So in the beginning of the slide, you showed a bunch of different implementations, including AWS and Redis and things like this, and also Azure. Like, do you intend to have a lot of implementation for a lot of things?
We are doing, so the question is, are we going to have multiple implementations for capabilities? And the answer is yes. We want to have different cloud implementations for those capabilities, as well as OSS components. And we are doing this per user request.
Yeah, and that's actually part of what we mean with the slide of let's build cool stuff together. You know, SpiderLightning and Slide, they're built very modularly, so it's very easy to contribute. If you want to contribute a new interface, you just go and you write a WIT file. If you want to contribute a new service implementation, all you need to know is the SDK for that implementation itself, and just implement the WIT interface. So we would love contributions on GitHub. Go ahead.
What WASM or WASI or component models or specification or feature are you most excited about? Like, what will make Slide tag better?
I have one. Do you wanna? Or actually just revoicing the question. So you're asking what are like WebAssembly component model, WASI, things that we're most excited about in the near future? Do you have one? I'm most particularly excited about the world's PR that we're getting in.
Yeah, I'm excited about the word syntax that you can have different profiles, or we call it words, of different capabilities, and you can use them, use different parts of those Lego pieces in your application. You don't have to bundle them together or bundle them with WASI. And another one I'm thinking about is the component model itself is a game changer. It introduces those higher level types that makes writing the capabilities as interface as possible. So that's the foundation of it.
Yeah, so hopefully in the future you can imagine SpiderLightning itself as sort of like a world, or the key values of SpiderLightning as a world. And very much excited for that. Yeah, please go ahead.
Is WASI and therefore SpiderLightning compatible with Cloud Events Android native?
Okay, so the question is WASI and SpiderLightning compatible with cloud native events?
Cloud Events
Yeah, cloud events.
and/or native.
Mhm.
We actually have a events capability, and that events capability, it's pretty similar to the HTTP server. You can listen, so each capabilities like key value or message queue, we want them to have a kind of like a watch function. You can watch for the key change to that key value store, and that will emit a cloud event. And you can write those event handlers in your application to handle those events. So that's part of it.
Yeah, a lot of that work still has to be done. For sure, we've only implemented watch for key value store.
Yes.
So that is also another good point to contribute. All right, any other questions?
Great. Thanks, guys.
Yeah, thank you so much.